All right, Lindsay, I wanted to make you a video real quick of 19, 21, 22, and 23. So for number 19, you have that graph where you have that, it looks like it's like a cubic function and there's a tangent line at a certain point, and this is at 2 comma 3. So you're given the function f, and this red line is the tangent line, okay? So you need to find g prime of negative 2. So they tell you that g of x is equal to e to the x times f of x. And your goal is to find the derivative of g at negative 2. So before we start looking at the graph and doing all this stuff, trying to figure things out, let's just, in general, figure out what the derivative of g would be. So the derivative of g is going to be product rule. You're going to need to use product rule. So this is u and this is v. So g prime of x would be u prime, which is e to the x, times v, which is f of x, plus v prime, which is f prime of x, times u, which is e to the x. So that's the general idea of what the derivative would be. Now we want to find specifically at x equals negative 2. So now you're going to plug in a negative 2 everywhere you see an x. So I'm putting it in all these spots. Okay, now e to the negative 2 is just a constant. So this could be written as 1 over e squared. F of negative 2 is actually the function value at negative 2. So this function, f at negative 2, that should be a negative 2 right there, is actually 3. So you plug a 3 in right there. And then f prime of negative 2, well, that's the derivative at negative 2. So the derivative at negative 2 is also 3, okay? So remember that the tangent, okay, is also the same as the slope, okay? So this is also going to be 3. And then times 1 over e squared, like that. All right, so now we can simplify. So 3 over e squared plus 3 over e squared again, and that's going to be 6 over e squared, which is choice A. Okay, so that's number 19. So the big thing there was to just figure out the derivative in general, then plug a negative 2 in everywhere. Okay, so for 21, number 21, you have a piecewise function. So you have ax plus b for all x less than 0, and then the other piece is e to the x for all x greater than or equal to 0. Okay, so if f is differentiable, find, you're looking for a plus b. That's the goal. So there's two things that you need to do with piecewise functions when they say that they're differentiable. If something is differentiable, then that means it is continuous and it's also has matching derivatives. So it's differentiable. Both of the pieces have the same derivative because you'd have to have the same slope coming in from the left as you do from the right. So that way it would be a nice smooth curve. Otherwise, if the slopes are drastically different, you're going to get that corner and you're not differentiable on a corner. So if it says f of x is differentiable, then that means it has to be continuous at that point, and the point that we're concerned about is at x equals 0, and it's also differentiable. So if it's continuous, that means the two pieces hook together. So you're going to say ax plus b equals e to the x. Where are they connecting? They are connecting at the point x equals 0. So you plug the 0 in everywhere you see an x. So this becomes a times 0 plus b equals e to the 0. That goes away. B equals anything to the 0 power is 1. So we got an answer for b. Now, the differentiable part, well, that means that these two pieces have to have the same derivative. So you need to take the derivative of the top and the derivative of the bottom. The derivative of the top is just going to be a. The derivative of the bottom piece is going to be e to the x. Where do these derivatives have to equal each other? Well, they have to equal at this breaking point right here, which is at x equals 0. So plug the 0 in for the x. A equals e to the 0. A also equals 1. Now, a lot of times we stop there because we think, all right, we got the answers, so the answer must be 1, but it's not because you are looking for A plus B. So 1 plus 1, the answer is actually 2, which is choice D. Okay. For number 22, number 22 is kind of tricky. It's kind of old material, back to limits. So 3e, 3 plus h like that, minus 3e to the 9th, like that, all over h. Okay, so this is the definition of a derivative. Okay, so you need to remember definition of a derivative is f of x plus h minus f of x all over h. Now, this one goes one step further, and it actually is evaluating the derivative at a specific point. So do you see how see the 3 plus h here? So that's kind of right here. So the 3 and the x, so x equals 3. So this is a derivative of a function at x equals 3. Okay, the x lines up with the 3. Now, this x plus h has been plugged into a function, and I see this e here and here. I see a 3 here and here. So my f of x is going to be 3e to the, now there's another 3 up here. Now remember, this is x plus h. So it's 3x is the function. Okay? Now, this is telling you in an old-fashioned limit to take the derivative of this. So we know how to take the derivative of that. We know that 3 is a constant. So this is e to the 3x times the derivative of 3x, which is 3. So your answer is 9e to the 3x. And we are evaluating this at x equals 3. So this is 9e to the 3 times 3, or 9e to the 9th, which is choice D. Okay, back here, this is f of x. This is also f of x. Actually, this is f of x evaluated at x equals 3. So if f of x is 3e to the 3x, this becomes 3e to the 3 times 3, and that's why that is 3e to the 9th back there. So I know this is fast, but take a minute to look at it and then pause it and rewind it and stop it in little points so that way hopefully it'll work for you. Okay, so then you had one more, which was the number 23. And so for number 23, oh goodness, a unicorn. A unicorn moves along the x-axis so that its position in time t in seconds is given by x of t. So this is the position function, equals 3 times 1/2 raised to the 2t. In feet per second squared, okay, that's a hint. Feet per second squared. That means you are looking for acceleration. Okay, yeah, and they ask you that. What is the unicorn's acceleration at t equals 1? So you are looking for acceleration, which is the second derivative. So you're looking for d2 over dx2, okay? d2y over dx2. So that's the goal. So the first derivative is going to be this constant, 3, times the derivative of an exponential function. So it's going to be 1/2 raised to the 2t times natural log of 1/2 times derivative of 2t, which is 2. All right, this is a constant, and so is the 3. All of these things are constants. So we can bring that out into the front. So let's see, how about 6 natural log of 1/2 times 1/2 raised to the 2t. So now we are going to take the second derivative. Second derivative, this is all a constant times the derivative of an exponential. So this will be 6 natural log of 1/2 times 1/2 to the 2t times the natural log of 1/2 times the derivative of 2t, which is 2. Okay? Okay, so I know I can finish this up real quick for you. So now, what do we have? We have a 6 and you have a 2, which is 12. Also, we can evaluate this now at, so evaluate this at x equals, or not x, t equals 1. Yeah, t equals 1. So we can put a 1 right there. So that would be 2 times 1, which is just 2. So that this becomes another constant, so times 1/2. And then times the natural log of 1/2 and all of that squared. Okay, so 12 divided by 2 is 6. I'm looking at the multiple choice and I'm noticing that none of them match yet, but we're getting there. This right here, so that takes care of this. This is properties of logarithms. So this is going to be times. If you have division, it turns into subtraction. So this is going to be natural log of 1 minus the natural log of 2, and then all of that squared. Okay? The natural log of 1 is 0. What else can we do here? So this would be 6 times negative natural log of 2 squared. So you could, let's see, what else could we? Hey, Lindsay, I was looking over my work again, and I just realized when we were doing this 1/2 was raised, should have been raised to the 2 times 1, which we had, but then I never squared it. So this should become a 4 down here. You probably have a 2 in your work right now. So this would be 1/2 squared, which is actually a 4th. So that should become a 4, which is why I didn't see the correct multiple choice answer. So 12 divided by 4 is 3. Still all the same simplifying we were doing before, just a 3 in the front instead of a 6. And then when you square this, like negative natural log of 2 squared, negative squared turns positive, and then it's just natural log of 2 squared times 3. And that's your answer for number 23. Hope that helped.